It's really a pleasure to be here. I used to actually live in Dallas, and it's nice to be back. A little word about the format tonight. I'm going to lecture for about 50 to 55 minutes, and then we'll have an open Q&A with mics on both sides. And so I'll look forward to that conversation afterwards. And I just wanted to tell you a little bit about the Q&A by way of contrast to my own experience as a graduate student in England. When I was first-year graduate student in Cambridge, I was very intimidated by the whole British scene. And one day there was a guest lecturer who came to our department who was lecturing on the famous philosopher Immanuel Kant. And I had had one course on Kant's philosophy as an undergraduate, but he was going way beyond anything I'd ever heard or learned. And so I asked a question that revealed some ignorance, I guess, and I asked him if he had a source in Kant's writings where I could learn more about what he had been lecturing on. And there was some awkward, uncomfortable shuffling of feet in the audience or in the classroom. And he obliged me, gave me a source. But afterwards, my supervisor took me aside and said, Meyer, he said, I know in the States you've learned that the only stupid question is the one you didn't ask. It's different here. And then he said, if you have a question in future that reveals ignorance, come ask me privately. And he went on to say that he said, everyone here is bluffing. And if you're to succeed, you must learn to bluff too. So anyway, we'll have a Q&A afterwards, but it will be American rules. That is, no stupid questions, nothing considered a stupid question. Okay, let's dive in. I've written a book called Darwin's Doubt, and I'm going to talk about it tonight. But I want to talk about another experience I had in Britain more recently. This was about a year ago. It was November of 2016. It was actually the week of the election, which was almost surreal to be in Britain watching all the events in the United States on British television. But the event I attended was the annual conference of the Royal Society of London, which is the world's oldest and arguably most august scientific body. And the Royal Society conference that year was called to assess the current status of evolutionary theory. In particular, it was called to look for a new theory of evolution beyond the standard textbook theory that we all learn in high school and biology college or textbooks, the theory of neo-Darwinism. And many of the evolutionary biologists who were there at the conference and who had called the conference were profoundly dissatisfied with this standard evolutionary theory. And one of those evolutionary biologists was a leading Austrian scientist named Gerd Müller, who gave the opening talk titled "The Explanatory Deficits of the Modern Synthesis." Now, the modern synthesis is just another name for standard modern Darwinism or modern neo-Darwinism. And in his lecture, he listed 5 major deficits of the theory. I'm going to focus on 3 just to open this up. And the first was the problem of the origin of what's called phenotypic complexity. The phenotype is the visible body structure of an organism. And Professor Müller was saying that the mechanism of mutation and natural selection really doesn't explain the origin of these new body plans and body types that we see in the history of life. He also talked about the problem of the origin of anatomical complexity, or rather anatomical novelty. The mutation selection mechanism seems to do a pretty good job of explaining where we get small-scale variations. The Galapagos finches that get their beaks a little longer, a little shorter in response to varying weather patterns. But it doesn't do a good job, he argued, of explaining where we get things like birds in the first place. And thirdly, he talked about the origin of non-gradual modes of transition. That just meant the abrupt appearance of new forms of life in the fossil record. So basically, the 2 big problems are explaining the origin of novelty and complexity, where the new forms of life come from, and explaining why they appear so abruptly in the fossil record. Now, this lecture was something that a number of us in the intelligent design research community could have written or had written ourselves. We'd been saying many of these same things about the deficiencies of neo-Darwinism for many years. It also connected to a theme of my book, Darwin's Doubt, in which I argued that there has never been a greater disparity between the public presentation of the status of a theory in the popular press by people like Bill Nye the Science Guy, on PBS documentaries, in biology textbooks, in the statements of science writers for the New York Times, or policy statements by the National Academy of Sciences, and the like, on one hand, and the actual status of the theory as you find it in peer-reviewed technical articles within biology and even within the field of evolutionary biology, or even at major conferences, such as the one several of us attended at the Royal Society in 2016. Just to illustrate, look at this disparity. I've just shown you the skepticism of a leading evolutionary biologist. This is a statement from a proponent of what we call the Darwin-only approach to science education. Her name is Eugenie Scott. She was the past president of the National skipping my mind all of a sudden, an organization out in Oakland, California that is advocating a Darwinian approach to science education. I was here in Texas for the State Board of Education hearing in 2009. There was a proposal before the State Board to encourage teachers to teach the strengths and weaknesses of different scientific theories. And Eugenie Scott of the National Center for Science Education, was out, and her group came in force to oppose this seemingly common sense standard. She said you can't apply the idea of strengths and weaknesses or teaching about them to Darwinian evolution because, she said, there are no weaknesses in the theory of evolution. She was quoted as saying this in the Dallas Morning News just before the hearing. At that hearing, I entered into evidence 100 peer-reviewed articles within evolutionary biology journals and other biology journals documenting really difficult problems in evolutionary theory, but Dr. Scott told the board there are no weaknesses. Or another such statement that I actually kind of enjoy, this is from Richard Dawkins. He's the leading proponent of modern neo-Darwinism, a former Oxford professor, written books like The God Delusion and The Blind Watchmaker. He was quoted as saying, it is absolutely safe to say that if you meet somebody who claims not to believe in evolution, that person is either ignorant, stupid, or insane, and then he says parenthetically, or wicked, but I'd rather not consider that. I thought that was sporting of him not to consider that people who disagreed with him might not be wicked. Anyway, it's that kind of dogmatic statement juxtaposed against the actual skepticism that you find in the peer-reviewed scientific literature that creates this disparity that I'm talking about. It's very strange. You've got this public relations campaign for modern Darwinian theory, and yet scientists who work in the field are saying, we need a new theory. Very strange. And so Gerd Mueller and a co-author, Stuart Newman, in a book published by the MIT Press back in 2004, called The Origination of Organismal Form, put it this way. They said, neo-Darwinism has no theory of the generative. That's the big problem. It doesn't explain where new things, fundamentally novel things, come from. Or many biologists today are saying that it explains the survival, but not the arrival of the fittest. It explains small-scale variations, but not major innovations. And in addition to Mueller, you have other leading figures saying similar things. This is Lynn Margulis, the late Lynn Margulis, only died a few years ago, from University of Massachusetts, leading evolutionary theorist. She says, mutations, in summary, tend to induce sickness, death, or deficiencies. No evidence in the vast literature of hereditary change shows unambiguous evidence that random mutation itself, even with geographic isolation, leads to speciation, leads to fundamentally new things. Now, to put this criticism that we're finding in the biology literature in context, it might be helpful to define the term evolution and to recognize the different meanings of evolution the term may have. One meaning of evolution, perhaps the simplest, most straightforward meaning, is the idea of change or change over time. And this is not really a very contentious definition. Almost everyone accepts this kind of evolution. That life today is different than it was a long time ago, for example. That's one sense of change. We had long ago trilobites and triceratopses, and we don't see them swimming around or running around out on the quad. So life is different now than it was a long time ago. Another sense of change, which is also pretty much incontrovertible, is the small-scale variation that I described a bit ago with the Galapagos finches or the peppered moths. You may remember them from a biology class, the moths that were darker and then lighter and then darker again as a general rule in the population. So you had a cyclical variation in the frequency expression of the same basic traits. You had dark moths and light moths at the beginning and dark moths and light moths at the end, but what changed over time was the relative frequency of the expression of those traits. So that's a kind of what's sometimes called microevolution, and that's really uncontested. Another sense of change over time. Now, another meaning of evolution, a second definition, is the idea of universal common descent. And that's the idea that all organisms come from a single common ancestor, one or very few, a long time ago, and that the history of life is best represented as a kind of great branching tree, where the branches at the top of the tree represent all the forms of life we see today, and the connection points going back all the way to the beginning are a representation of the slow, gradual, continuous process of change that has produced all living things. This is a sense of evolution. This sense of evolution implies continuous biological change from that original common ancestor. Now, this sense of evolution is a bit more controversial. Many biologists will tell you it's a fact, but there are also an increasing number of biologists who question this, in part because the fossil record does manifest not a gradual transition from one type of thing to another, one type of organism to another, but instead, especially when we're talking about major new groups of animals, abrupt appearance that doesn't seem to give any evidence of that kind of gradual, continuous change that's depicted in the Tree of Life. The book I wrote, that I'm talking about tonight, Darwin's Doubt, talked about an event in the history of life known as the Cambrian explosion, when the first major forms of animal life appeared abruptly in the fossil record. And this has been puzzling to scientists from Darwin's time forward, because according to Darwin's theory, we should expect to see this tree-like pattern. Instead, we see, with respect to the first animal forms, what I represent with the gold dots on this diagram behind me. We would expect to see also all those blue dots and a series of intermediates or ancestral forms leading to the new forms of life, but instead we see the new forms appearing abruptly without any discernible connection to animals that are similar in the lower sedimentary strata. So this abrupt appearance is a reason to question the idea of universal common descent. So the origin of the animals, sometimes represented by the largest group in the classification system called the Phyla, the origin of the new animals appear abruptly, represented by those gold dots. We would expect to see underneath some discernible connections to ancestral forms. We just don't see them. And so there's this tension between theory and data, and the picture of the history of life that expresses the idea of universal common descent doesn't really seem to match the picture that we find in the fossil record. And that's a reason that some scientists have come to doubt the second meaning of evolution. In fact, Darwin himself expressed doubt not about that particular aspect of his theory, but he doubted that the evidence supported that aspect of his theory. He thought eventually the missing fossils would be filled in, but in The Origin of Species, he wrote, as to the question why we do not find rich fossiliferous deposits belonging to these assumed earliest periods prior to the Cambrian system, the Cambrian animals arising in the fossil record, he says, I can give no satisfactory answer. And he went on to say that the case at present must remain inexplicable and may be truly urged as a valid argument against the view here entertained. This is what I called in the book Darwin's Doubt. He didn't doubt that his theory was true, but he was puzzled and he doubted the adequacy of the theory to explain the evidence. Now, it wasn't just Darwin. These doubts about universal common descent have persisted right up to the future, or up to the present, rather. And you may have seen, well, this is a little bit dated now, but this was a Time magazine cover story in the mid-90s. And it was about a huge fossil find in southern China, which actually made the problem of the Cambrian explosion more acute because it documented many new forms of animal life that had not been known before, each of which was lacking ancestral intermediates or ancestral forms in the lower strata. And the Chinese paleontologists who were at the forefront of these discoveries expressed a lot of skepticism about Darwinian evolution. One of those professors, J.Y. Chen, actually came to the United States